Hi everybody, this is Mrs. Kress and I'm going to be going over how to name acids and bases and salts with you. First step is to know that bases are ionic compounds. Ionic compounds include things that are metals and nonmetals. So metal and a nonmetal. When you look at a periodic table, remember that your nonmetals are over here on the right. Sorry, really funky zigzag line. And then your metals are going to be over here on the left. Now remember, on this box right here are going to be the transition metals. Transition metals can go in between having different charges because they have different number of valence electrons. So you're going to have to look at a periodic table, and if the element has more than one valence electron that it can have, and it will turn into a different ion, and it's considered transition metal. So if that is the case, then you're going to need to use your Roman numerals in order to name that metal. So for example, our first example is going to be sodium hydroxide. Notice that sodium is the metal, and I just leave the name the same because it's not a transition metal. It does not get a Roman numeral. Now, the second word, hydroxide, is the polyatomic that is always at the end of a base. So when you see OH, all you need to do is write hydroxide. So down here at the bottom, we have KOH. K is going to be potassium, so you would write potassium, and then hydroxide because it has an OH. So that's it, potassium hydroxide. Some other ones over here are going to be nickel, iron, tin, and cobalt. All of these are considered transition metals, so you're going to need to look at the number that's on the outside of the hydroxide to tell you what Roman numeral you need to write. So this one isn't just cobalt hydroxide, it's cobalt 2 hydroxide. You guys get the gist. This one isn't just nickel hydroxide, this is nickel 2 hydroxide. So again, you would write Roman numeral 2 and then hydroxide. So let's do another one. Okay, so salts. Salts are actually really easy because we've already gone over what salts are, and salts are anything that has a metal and non-metal. They're any ionic compound. So again, just like for bases, you're going to write the name of the metal first. So in all my examples, I have calcium, I just write calcium. I have lithium, I just write lithium. I have cesium, I just write cesium. Now, the other part of this is looking at your non-metal. Remember, if you have something like fluorine, which is right here for our first example, you're going to get rid of the ene ending and add IDE. Same thing for the second one. We have chlorine, and you would get rid of the INE and add IDE. Now, for this last example, I have a polyatomic. I have added the polyatomic sheet to your Schoology account, so you guys can go and use that. Oh, I also have the periodic table there too for you guys to use. So what I like about polyatomics is that you can just go to the polyatomic sheet and look up PO4, and it will tell you that it is phosphate. So again, just write the name of the metal, which is cesium, and then if it's a polyatomic, PO4, just write whatever that polyatomic would be at the end. Again, if you're looking down here at your examples or your sample problems, there are a couple of transition metals that I threw in there for you. So you're going to have to look at these numbers over here to tell me what ion that transition metal was. So for number 3, MnF, that would be manganese fluoride, but because manganese is a transition metal, we have to say it's manganese 7 fluoride. I'm going to tell you number 7 is a simplified one. Sulfur is supposed to have a -2 charge. So where did that 2 go? You guys will have to figure that out and remember how to do that. And last but not least, we're going to go to our acids. Acids are, I guess, I wouldn't say they're tricky. They're just a new thing that we're learning. So first thing that I have up here for you guys is to know your common element roots. So carb for carbon, nitra for nitrogen, ox for oxygen, fluor for fluorine, iode for iodine, hydra for hydrogen, phosphor for phosphorus, sulfur is just sulfur, chlor for chlorine, and then selene for selenide. Now, and brom for bromine, sorry. Now, why is this important? Well, acids always start with hydrogen. So anytime you have a compound that is going to have a hydrogen in front, it's considered an acid. So followed by a single nonmetal or a polyatomic ion. So as you can see for all of your examples here, they all begin with hydrogen. So my first one, the naming practices all has to do with the ending of the nonmetal here. So HF, well, there's hydrogen and then there's fluoride, right? So fluoride is going to be your ending. Anytime you have fluoride or an IDE ending, you're going to have the acid naming system of hydro, the root word, and then ic. The whole reason why I went over the root words with you at the beginning was so that you knew what to put in there. So if we go back and we look here, and we say, okay, well, it's fluoride, so the root of fluoride is going to be fluor. So just put fluor into where it says root in the naming. So you would have hydrofluoric acid. So then if you look at it over here, it has hydrofluoric acid. I know, it sounds easy when I say it, right? Or I think it sounds easy. So the next two are going to be if you have polyatomics. So polyatomics, you either have an 8 ending or an ite ending. So 8 is going to be anything that ends in 8, and obviously ite is going to be anything that ends in ite. Notice you're still using the root of the word. So if you have chromate, chrome is going to be the root word. Here you have nitrite, nitra is going to be that root word. So again, taking that root word and popping it into how you name it. So this would be chromic acid. And again, if we look over here to the side, chromic acid. Nitrite, again, you would have your nitrate goes into that root part. So nitrous acid is going to be the name of your acid over there. And then again, you look over, you have nitrous acid. So what I did was I broke this up for you. I have the binary. Binary is anything that ends in ide. Okay, bi just means two. So like H3N is going to be a binary because all you have is hydrogen and nitrogen, which is two things. That's where bi comes from. So for example, down here we have, let's do number 5 because we've done 5 a bunch of times. So you probably already know what number 5 is. So we have H and Cl. So Cl is chloride. And because anything that has an ide ending, when you go back up here, you look and you say, all right, well, if I have an ide ending, that means that I need to be using this naming method. So if I had chloride, then this would be hydrochloric acid, which is what I would end up writing down on the bottom. So for number 5, you would end up writing hydrochloric acid. Okay. So for some other ones down here, we have things that end in 8. And again, so the first one I have chlorate. So my root of my word is chlor. And if I go back up here and I say, all right, I need to figure out what 8 is again. Oh, look at that. It's right there. So anything that ends in 8 is the root word, which is chlor, and then I add ic to it. So my name is chloric acid for this example down here. And last we have is ite, and again, same thing. Whoops, sorry about that. Same thing. My first one is nitrite. So if I'm looking at nitrite, I have nitrate as my root. Now I'm going over here and I say, all right, so oh, look at that. Nitrate is already my example. Whoops, didn't mean to do that. But again, you have the root, which is nitra. Because it started out with ite, you're going to have nitrous acid, and then that is going to be your name, and that can go down over here. So I hope that helped you guys out. I know I just kind of did a whirlwind through that, but if you need me to go over specific examples with you and everything, just let me know, and I'll be sure to help.